heat pump is a renewable source of heat. It's an alternative to a boiler, but rather than using gas or oil to generate the heat, it's using electricity to harvest environmental energy. In really simple terms, a heat pump takes heat energy from the air or from the ground, even at really low temperatures, passes this through a compressor circuit to increase its temperature to supply all of your heating and all of your domestic hot water. It can do this in temperatures as low as -20 degrees, which is way below what we'd expect to experience in UK wintertime. The heat pump absorbs the latent heat energy into a refrigerant. This process increases the energy content of the refrigerant, changing it from a liquid into a vapour. The vapour is then compressed by an electrically driven compressor, which increases its pressure and therefore its temperature. The condenser then liberates this heat energy into the water that's then used in the heating and the hot water system. In a well-insulated building with a good heating system, the heat pump will transfer 3 to 4 times more energy into the property as heat energy than it uses electrical energy to extract it.
Now, heat pumps are becoming more and more popular. It's something you may wish to consider for your project, but you must remember that one size does not fit all. Okay, so the first thing to take into consideration is the actual heat output of that said heat pump. Can it provide enough heat for your property? And that's why our initial statement on the fabric first approach becomes really, really important, because it will determine the size and output of the heating system required for your property. Now, the other thing to think about is the actual location of the heat pump. And we're talking air source heat pumps in this situation. They are quite large bits of equipment, and you need to find a suitable position around the outside of your house for that to fit. Now, if you have a listed property, you have to have listed planning consent to actually have that heat pump fitted. Otherwise, it's normally under permitted development.
So how do you know if a heat pump is suitable? There are some really important considerations that will tell you whether it's the right choice or not. To keep it simple, there are 3 things to ask. Number 1, how well insulated is the property? Like with any heating system, it's important that the home is warm and that the heating bills stay low. The better insulated the property is, the lower the heat losses and the less energy required to heat the home. Ideally, you want to be insulated up to or as close to current building regulations. For this reason, in a new build, a heat pump is likely to perform excellently. If it's a renovation project, then you do need to do all that you can to improve the insulation to minimise your heat losses. We're talking walls, windows, floors and roof. But if it's poorly insulated or poorly designed and installed, then it's not going to be efficient or economical and completely negate the point of having a heat pump. Number 2, what's the heat emitter? A heat pump is at its most efficient when producing low water temperatures. To effectively heat the home with these lower temperatures, you absolutely need to install a suitable heat emitter. Ideally, warm water underfloor heating, or you need to look at large surface area radiators. I'll go into more detail on this a little bit later on. Number 3, what is your aim? It's really important to understand what it is that you're looking to achieve by the installation of a heat pump. If the driver is environmental, a heat pump matches this expectation. But if the belief is that a heat pump will cost far less to run when the property already has mains gas, then it's not such a good match. When it comes to suitability, this is where an experienced supplier or installer can really help. A good understanding of heat pumps, knowing how to design an efficient low temperature heating system, will mean that they can honestly tell you whether a heat pump is a viable option for your property. It's also worth checking if the supplier supports a system after it's been installed. It just gives that extra confidence that they stick by the system that they're designing for you. It's so important. So to recap quickly, a heat pump is best suited to well insulated property, designed together with a low temperature heat emitter, which is ideally underfloor heating.
Next thing to think about is actually how you're distributing the heat around the property. Traditionally, we've used radiators, which is still a very good option, and there are many different styles and options on the market. But one thing you have to consider is that when you're heating your house with a heat pump or a modern gas system, that the actual flow temperature is going to be lower. And this has the impact actually on the physical size of the radiators, and it will be bigger than what you're used to previously. Now, another very good option is underfloor heating, and it has become incredibly popular over the years. We all like to have free walls with no space required for radiators. But you must be careful with underfloor heating because you will only give the heat output of the floor area that you have. But also, the actual floor finish has a big impact. So using stone or ceramic tiles will give you a good output, where if you put carpet on, that will reduce the output significantly. So it's a very important factor to take into consideration. You may want to fit a wood burning stove, which can be very attractive and a very nice thing to have on a very cold winter's night. But they can be quite expensive, and you've got to look about the viability of this. But also make sure that your property is not in a smoke-free area where you may have issues where you actually be able to use it.
An underfloor heating system is essentially made up of strong and flexible pipework that's installed under or within the floor with warm water running through it. The water is supplied to the underfloor heating by a heat source, like a boiler or a heat pump, and it's fed into the manifold. The manifold controls the flow of water to the underfloor heating pipework and regulates the temperature. This warm water then heats the floor, transferring a gentle and even heat into the room above.
Whilst using existing pipework, our recommendation is if your heating system hasn't been power flushed, certainly for the last 8 years, it's not worth actually power flushing. You could end up creating problems. Instead, replace your radiators. That's the first challenge. Replacing your radiators may increase the performance by up to 30%. In the retrofit market, there is a misconception that if I'm changing from a boiler system to a heat pump system, do I need to oversize my radiators? The answer is actually no. You can consider fan-assisted radiators. In particular, at Zehnder, we do produce a Zehnder Nova Neo and the Lateo Neo. These radiators have fan-assisted convection with them, which allows the heat to be pumped more around the room. Something else to take into consideration is also our Zehnder Terraline Neo, or our Terraline Fresh system. That has the ability to produce heating and cooling within the room.
Ventilation is a part of our property that quite often is misunderstood or sometimes even forgotten about. Fresh air is important. If we don't have fresh air in our homes, then we can have what we call sick building syndrome, where effectively the air quality in the building becomes incredibly poor. Now, ventilation in properties, if you're building anything new, like an extension or so on and so forth, will be covered by building regulations. But traditionally, we either open windows or we have little things called trickle vents, which are little slots above the top of your windows. And we must open and close these as required to ventilate our properties. Now, an alternative is what we call mechanical ventilation with heat recovery. This is a whole house system which naturally ventilates your property beautifully, and you have fresh air in your property all the time and negates the requirement for any extractors or any other vents. But if you are going down this route, the air tightness of the building becomes incredibly important, because if you do not have an airtight house or relatively airtight house, the MVHR system will perform very poorly.
And as you make the building more airtight, it becomes more and more vital to make sure your air quality is good. So I would recommend that you try and look at the ventilation system very early on in your build and your renovations, so you can do more things as you go through. A full MVHR system like this could reduce your energy demands by up to 15 to 20% by keeping the heat back within the building.
Mechanical ventilation systems with heat recovery, or MVHR for short, is a system that is predominantly designed to extract stale, smelly, moist air from a property, and at the same time it's designed to bring in fresh filtered air from outside. But the most important aspect about this system is that it should be able to recover over 90% of the heat that's been extracted from the property and put that back in at the same time. And that also helps to keep your heating bills down. The air is typically changed in the house 10 times a day, so it keeps it fresh and healthy all year round. Now, during the summertime, heat recovery is not normally required. The summer bypass on the units should kick in to introduce slightly cooler air back into the building, which will try to help with any potential overheating issues. The main crux that we have with MVHR systems going into renovations and existing buildings is that we have to fight with the existing structure of the building, which could be solid joists, steels, pipework and other obstacles. So it's very important that the system is designed bespoke for the given property to ensure both compliance of the system and also to guarantee any manufacturer's warranties.
So, in summary, if you're considering using an air source heat pump or ground source heat pump, then you have to think about the location of the plant, the peak heat load, and also that in connection with the thermal performance of the building. This becomes incredibly important. This also connects to your heat delivery, i.e. size of radiators and floor heating and the like, but also ventilation also ties in as well, because if you have a building with mechanical ventilation, it will therefore have a lower peak heat load than a building which is naturally ventilated. So effectively, we have to have a holistic approach about the whole system, because if you change one element, it will affect another element. So this all has to be taken into consideration.